Hello, my name is Eugene Kiselev, and I'm an economics PhD student at Brandeis University. I'm very happy to present my work, which is titled Bribe-Taking in Bureaucratic Competition, a Search Cost Model of Corruption. The primary objective of this research is to find a new approach to modeling the relationship between firms and potentially corrupt bureaucrats when firms are in need of licenses, permits, or other services that a bureaucrat can provide. When a firm is interacting with a single bureaucrat, the relationship is generally dominated by the bureaucrat, who has basically all of the bargaining power in terms of his ability to extract a bribe in exchange for the service. Otherwise, he can simply deny the service. Economic theory has been searching for a solution to this problem, and a famous one that has been proposed is the concept of bureaucratic competition, which is essentially competition between bureaucrats for the provision of certain services. Basically, if multiple bureaucrats in the same or different departments are competing to provide a service to a particular firm, then competition may push down the bribe price demanded, because firms can simply reapply to another bureaucrat if the first one solicits them for a bribe. This idea of competition between different departments is usually referred to as the principle of overlapping jurisdictions. So the primary objective of this paper is to model bureaucratic competition among corrupt bureaucrats and determine its effect on bribes that bureaucrats solicit. And after proposing a model that captures this relationship, I'm going to use Russian firm-level and region-level data to test the model and determine whether in fact bureaucratic competition affects bribes in Russia. So this paper contributes to the existing literature in two very important ways. First of all, I present a new model to capture the interaction between bureaucrats and firms when bureaucrats must compete for bribe revenue. The model focuses on the most salient aspect of this relationship, which is the firm's cost of reapplication, or basically their search cost. Secondly, I provide one of the first empirical tests of the effectiveness of bureaucratic competition in reducing bribery, again using the Russian dataset. In the interest of time, I'll provide a short outline of the model. However, I won't be discussing the derivation of the model and equilibrium in any detail. The model is an adaptation of one first proposed by Dale Stahl. There are n is greater than or equal to 2 government agents providing required licenses to a unit mass of firms. I assume all agents are corrupt and demand a bribe for the license, and each firm requires exactly one license. Firms arrive randomly to an agent who solicits them for a bribe, and then a firm may search sequentially among all remaining agents for the lowest bribe price. All bribes are private information to an individual agent, so other agents are not aware of the previous bribe price that a firm may have already rejected. The relevant model parameters are as follows. A proportion alpha of firms are willing to pay bribes, whereas the remaining 1 minus alpha are not, and in fact report on corrupt activities, leading to a fine being assessed to the agent. This fine is modeled as a multiple of the bribe amount solicited. Of the firms willing to pay bribes, a proportion mu can search without cost among all bureaucrats for the lowest bribe price, whereas the remaining 1 minus mu all have a constant and identical search cost c for each bureaucrat they visit after the first. An important assumption here is that there is zero cost to visiting the initial bureaucrat. And a simple interpretation of zero search costs is that firms have a low value of a license and don't need it immediately. It could be that their previous license is not yet expired, or that this license is simply not a major priority. So these firms can search among all bureaucrats and end up paying the lowest amount. On the other hand, positive search cost firms are in more immediate need of the license. Their search cost represents a time cost of delayed operation in one form or another. Agents don't know an individual firm's type, but they do know the distribution of types in the economy. Though I haven't included the derivation in this presentation, what is most relevant here is that with both positive and zero search cost firms, there is no equilibrium in pure strategies. This means that in mixed strategies, there is going to be an equilibrium distribution of potential bribe prices that each agent is willing to charge. In the next 2 slides, I'll present the results of the simulations that show how this equilibrium bribe price distribution changes when we change one of the relevant model parameters. If you are interested in a more comprehensive look at this model and its results, I would refer you to the paper, which is available on SSRN. So what we're looking at here are different bribe price distributions for a single agent, and since agents are identical, this is really the bribe price distribution of all agents. The x-axis shows the bribe price, while the y-axis shows the cumulative distribution as a function of the price. The leftmost graph presents the change in the equilibrium bribe price distribution when the proportion of firms willing to pay bribes steadily rises. I hold the other parameters constant, and you can see their values below the x-axis. And I look only at the change in the distribution brought on by increasing bribe-paying firms from 65% to 95%. As you would probably expect, this results in higher median bribe prices being solicited and more profits for the agents. The table also presents the results on the lowest bribe price that an agent solicits, as well as a firm's reservation price, which is simply the highest price that they're willing to accept. The middle graph shows the change in the bribe price distribution when the proportion of firms that can search without cost rises. Again, the results are intuitive, showing that both agents' profits and the bribe prices are falling. It's clearly in the interest of an agent to find firms who are in greater need of a license, as they will have more bargaining power to extract higher bribes. Finally, the graph on the right indicates that as search costs rise, bribe prices also rise, as do agent profits. If it's costlier for a firm to visit a second bureaucrat, they're more likely to accept a higher bribe price being offered, and this is what these results are showing. So this slide presents the main result of the model, which is what happens to bribes when we increase bureaucratic competition by increasing the number of competing agents from 2 to 5. I find a very interesting result, which is that bribe prices are actually rising with increased bureaucratic competition. The reason for this result is that agents realize that pricing high more frequently will net them higher payoffs. Soliciting a low bribe price attracts the firms that can shop around with zero cost. But with increased competition, the strategy is riskier because the probability that the price an agent charges is the lowest has now gone down. So agents are banking on the positive search cost firms who have a high demand for the license. They understand that these firms cannot afford to shop around and are more likely to accept a high bribe. In effect, the potential loss of bribe revenue from increased bureaucratic competition forces these bureaucrats to focus exclusively on the subset of the firm distribution over which they have monopoly power, which is the positive search cost firms. I'd like to point out that this model does not entirely reject the idea of bureaucratic competition as a way to reduce the corruption burden. Again, as search costs move to zero, bureaucratic competition does have the intended effect. However, this model indicates that the cost of reapplication is very relevant in measuring the effect of competition, and in situations when this cost is too high for too many firms, bureaucrats can carve out small monopoly markets for themselves and actually demand larger bribes. So, to quickly reiterate, the theoretical model indicates that an increase in bureaucratic competition can actually lead to larger bribe payments if there are enough firms with positive reapplication costs, or if these costs are sufficiently high. I test this result of the model using Russia as a case study, and I focus exclusively on the concept of bureaucratic competition. While testing the effect of search costs would be a welcome addition to the analysis, it's very difficult to extract this model parameter from any data set, and you would imagine this is something very firm-specific and likely unobservable. So I proxy for bureaucratic competition with the size of the regional bureaucracy per 1,000 employed population, using data from about 100 of Russia's regions and autonomous territories. I'll present the results of two analyses. The first one is the relationship between actual bribe payments made by firms and bureaucratic competition, while the second analysis uses panel data with information on size of average fines paid for economic crimes, which I'll explain shortly is likely correlated with actual bribe payment amounts. And again, I test the relationship between the second variable and bureaucratic competition. So the firm-level data on bribe payments comes from the Business Environment and Enterprise Performance Survey conducted by the World Bank in 2009, while the region-level indicators for both average fines for economic crimes and regional bureaucracy, which is used in both analyses, comes from Росстат. The reason I am confident in using average fines as an alternative measure to capture bribe payments is that multiple Russian sources indicate that at least 30% of all economic crimes in Russia involve bribe-taking by bureaucrats, and that the majority of these cases results in a fine being levied on the bureaucrat, which is some multiple of the bribe amount transacted. This means that there should be a relatively stable linear relationship between fines for economic crimes and actual bribe payment amounts. So the first analysis determines the effect of bureaucratic competition on actual bribe payments. I perform both a simple linear regression as well as a Heckman correction model to account for potential non-response bias in the survey data. In the xj vector, you will find all the relevant control variables. Log government 1k is our variable of interest, and we see that the coefficient is positive and significant, indicating that bribe payments are increasing in regional bureaucratic competition. And this is the most direct test performed in support of the main result of the theoretical model. Now I'll present the panel analysis of average fines paid for economic crimes. I perform a fixed effects regression with the average fine for an economic crime in region I and year T as the dependent variable, and bureaucratic competition as the main explanatory variable, as well as a number of control variables. Again, I find that bureaucratic competition is statistically significantly associated with higher average fines for economic crimes. As mentioned previously, these fines do include both bribe and non-bribe related crimes, but it's difficult to believe that more bureaucratic competition is increasing fines for non-bribe related crimes because there's no strong economic intuition for this relationship to exist. So it's much more likely that the average fines are rising for bribe-related offenses exactly because more bureaucratic competition leads to higher bribes. So, to conclude, this paper presents a new model of the interaction between bureaucrats and firms when corrupt bureaucrats provide a service, such as a license, that a firm requires. When firms have reapplication costs, I show that increased bureaucratic competition can in fact increase average bribes being solicited. And finally, the model results are supported by an empirical investigation suggesting that bureaucratic competition leads to higher bribe payments made by Russian firms. Thank you very much for tuning in.